Nobody goes into Sears and asks for a 6/8 wrench. They'll laugh at you. There's no such thing as a 6/8 wrench. They call it a 3/4 wrench. 3/4 inch is 6/8 reduced or simplified. So that we're all calling things by the same name, we have a convention of always simplifying our fractions. So I'll have to show you, so that you can speak with the rest of us regarding fractions, I'll have to show you how to simplify fractions. Consider that simplifying fractions is the same as canceling. You knew that. But it's really also the same as dividing by 1. Yes, dividing by 1. Nope, that's really what we're doing when we simplify fractions. Do you remember the division property of 1? This is the reason we learned it. In English, anything divided by 1 equals itself. 5 divided by 1 equals 5. You know why? Because you can go backwards and say 5 times 1 equals 5. Anything times 1 equals itself as well. Even a letter divided by 1 equals itself. Because we can go backwards. That letter times 1 equals x. So anything divided by 1 is not going to be changed. Remember about equivalent fractions. 2/4 and 1/2 were, quote, equivalent. They had the same value. They were at the same place on the number line, but they had a different name. What we did there was divide by 1 in the form 2/2. That's why we learned the division property of 1. And that's what we're going to do. We're going to divide by 1. In this form, 2 divided by 2 and 4 divided by 2. Have to do the same thing to the top that you do to the bottom, and you're really dividing by 1. Let's look at another example. 21/14 and 3/2 are really equivalent fractions. They're the same value with a different name. You know what happened? I divided by 1 in the form of 7/7. That's the division property of 1. You can divide by 1 anytime you want without dividing it, without changing it. Got to divide the top by the same thing you divide the bottom by. Got the idea? Now I want to show you a method that'll always work to simplify fractions. But before I do that, I need to define a couple words. Prime numbers are whole numbers. They're greater than 1, we don't include 1, whose only divisors are 1 in itself. In other words, they can't be broken up. Cannot be broken up anymore. Composite numbers, don't get confused, a composite number is a whole number greater than 1 that is not prime. In other words, it can be broken up. So they're opposites. Prime numbers cannot be broken up. Composites can be broken up. Give you some examples. 14 is a composite number because he can be broken up into 2 and 7. Get the idea? 6 is a composite number because he can be blown up, he can be broken up into 2 smaller numbers multiplicatively. Now 13, you can't break up 13. We're not including 1 now. His only factors are 13 and 1. We don't include 1, so he's prime. He can't be broken up. 5 is a prime number. And we're talking about multiplication. He can't be broken up. So we don't include 1 in our factors. So composite numbers can be broken up and prime numbers cannot. Now consider the prime factorization of a composite number. In other words, break a number up until it can't be broken up anymore into all of its prime factors. The prime factorization of 28, I'm going to break it up into 4 and 7. Now I'm not done yet, because 4 breaks up further into 2 and 2. So the prime factorization, you always put them in numerical order, by the way, is 2 times 2 times 7. That is the prime factorization of 28. I'll give you another example. The prime factorization of 90. Now it doesn't matter really how you start. I'm going to break it up in any way and then just keep breaking it up till it can't break up anymore. I'll break it, I know it's 9 times 10. Now both of those can be broken up further. So I'll break 9 up into 3 and 3, and 10 up into 2 and 5. So the prime factorization is 3 times 3 times 2 times 5, or, putting it in order, 2 times 3 times 3 times 5. That's the way to answer it. Now, you got to ask yourself, what if I had broken it up other than 9 times 10? It doesn't matter, is what I want to show you. Let's break it up into 2 times 45. It's still 90, isn't it? Now, 2's done. He's prime. But 45 can go further into 5 times 9. And 5's done, but 9's not. So I've got to break him up further into 3 and 3. Now, nobody at the endpoints can be broken up anymore. And son of a gun, did you note we got the same dad-burn answer that we got before? 2 times 5 times 3 times 3. Of course, we should put it in order. 2 times 3 times 3 times 5. Okay, doesn't matter how you start as long as you finish and breaking them up as far as they'll go. That's the prime factorization. Now, let's use a prime factorization in order to reduce a fraction. I'm going to take 8/12 and watch me reduce it. First thing I'm going to do is break them both up into their prime factorization, both the numerator and the denominator. That's the prime factorizations. Now it's easy to divide by 1 because anything over itself is 1. There's a 1, there's a 1, and I don't see any other pairs. So the answer, reduced, is son of a gun, is 2/3. And if you think about it, well, I took 8/12 and I really, in the long run, divided by 1 in the form 4 over 4. 4 over 4, which is another form of 1. 8 divided by 4 is 2, and 12 divided by 4 is 3. And there's your reduced fraction. How about something like this? Prime factorizations is maybe a long way to go, but it's still going to work every time. If I break 42 up as far as it'll go and 210 up as far as it'll go, that's what I end up with. Now it's almost fun. You start salivating a little bit because you start picking off pairs. The 2s, the 3s, and the 7s. Now this one's a little bit weird. What am I going to write? That's right. I have to have a top, so I'm going to have to throw a 1 in. Just remember, you don't have to have a bottom, but you do have to have a top. Now, what actually happened to 42 over 210 is that we divided by 1 in the form, believe it or not, 42 over 42. 2 times 3 times 7, it's much easier to deal with in that form, is 42. And 2 times 3 times 7 is also 42. So I divided by 1 in the form 42 over 42. And of course 42 divided by 42, that's why we had to write the 1. It's not 0. And 210 divided by 42, I promise, is 5. But you didn't have to do that. All you had to do was use prime factorizations. And we'll expect you to do that. Now it gets more difficult than that. Consider this problem. There are 1,500 students on the Germantown campus. 900 of them are above 21 years old. Suppose I asked you for a reduced fraction of students that are above 21 years old. Well, we do the selected over the total, which is 900 over 1,500. But I want a reduced fraction. We're not always going to tell you to simplify. You have to know to always simplify for the rest of your math life. If I break them up into their prime factorizations, wow, 900 is 2 times 2 times 3 times 3 times 5 times 5. And 1,500 is 2 times 2 times 3 times 5 times 5 times 5. It took a while, but once I have it, it's easy. All I have to do is pick pairs. Notice I'm picking something from the top and matching it with something from the bottom, because that's what 1 is. And son of a gun, that's the reduced fraction. You might not have ever guessed that. Okay? So if you don't know your multiplication tables by now, you will. Dig in and do the homework.